Hi everyone, Mr. Gilbert here, and this video is going to be about dew point and humidity, which is going to lead into clouds. And clouds are really going to hit by Mr. Kimpton in another video, but you got to know the basics. So let's start with some. Humidity. Well, you got to know what the word saturated means. When air can hold no more water vapor, it's saturated. Okay, can't hold anymore. It's like getting 100% on a test. You get everything right, you're saturated. Okay, humidity is the amount of water vapor in the air. It's a number, like a score on the test. They may say, oh, the humidity outside is 72 parts per million or whatever. Okay, it's a number. It's a given number. You record it as a number. What we often talk about and see on the news is relative humidity. The amount of water vapor in the air compared to the total amount of water vapor the air can hold. It's like a percent on a test. If the test was 100 points, and you had 90 out of 100 on the test, you got a 90%. If the air can hold 100 water vapor molecules and there's 90 in the air, the relative humidity is 90%. So that way it's easy to compare air of different temperatures because the warmer the air is, the more water vapor it can hold. If air is 30 degrees Celsius, it can hold almost 30 grams per cubic meter. Compare that to 10-degree water, which holds about 8 grams per cubic meter. So as long as we can say what the percent is, we can compare airs of different temperatures. That's why relative humidity is so important. We're going to take a little change of pace here. We're going to talk about dew point. Dew point is a temperature. It's the temperature air needs to be cooled to produce dew, or what we might call frost if it's cold, dew if it's above freezing, frost if it's below freezing. And that gets made basically at 100% relative humidity. In other words, if it's cold enough, gas is going to become a solid, or if it's warm enough, gas is going to become a liquid on something. Like in the summer when you get dew or water on the outside of your pop can, even though it started dry, but because it was nice and cold, it chills the air down next to the pop can and you get dew. The dew point is going to become important when we learn about forming clouds. So there's also a relationship that's really cool to know, and that's the relative humidity / dew point relationship. If the air temp, the temperature of the air, and the dew point temperature are close, the humidity is a high percent. In other words, if the air temperature, let's say, is 50 degrees, and the dew point temperature is 49 degrees, the relative humidity is going to be a very high percent. They're close. If it's far away, it's a low percent, and the air is dry. Okay? Dry air is a low percent. Moist air is a high percent. And of course, clouds form, which we're going to learn, at dew point temperature, where the air is basically 100% or near 100%. And if you raise the relative humidity or cool the temperature, you can get clouds, frost, fog, or dew. And we're going to show you lots of awesome things that work to get that on there. So without further ado, one of those. So how does a cloud form? Well, for a cloud to form, you're going to need 4 things. Water vapor. Of course, it's not a vapor anymore. We're going to make it into a liquid cloud or a solid cloud. You need that. Relative humidity is near 100%. The air must be humid. Doesn't matter the temperature of the air. The humidity or relative humidity needs to be near 100%. You got to have condensation nuclei in the air, lots of small particles of dust or salt or pollution or dandruff, so that the water vapor can condense around it or form solid ice crystals around it. And you need uplifted air. If you have those 4 things, you are going to form a cloud. And that will be Mr. Kimpton's video. So hope you enjoyed this one.